Is the end of winter near? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 18th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell, you get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like to make a special contribution, you can. Hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Our Predicament, Tim Caston, Evolution Moto, Kim in California. These are all longtime contributors, and a new contributor, Home Rank Network. Thank you so much. I really appreciate it. With that, let's get to work. But real quick, last week you noticed I was sick. I ended up with COVID. Ended up getting pretty bad. The point being here is if you get COVID, go and get tested really quick. And if you are positive, go get Paxlovid. It really makes a huge difference. I went from being down and out and not being able to hardly get out of bed to up and moving in a couple of days and feeling much, much better by tonight. So, do what you need to do. Stay healthy, stay safe, but get Paxlovid if you need it. And this is not sponsored. All right, let's move on now. We'll start by looking at significant wave heights of the North Pacific Ocean. We see a gale directly off the central California coast with seas in the 31-foot range, aimed directly at the coast. Swell from that system is pushing towards California. We also have an area of disturbed weather up in the North Dateline region, seas in the 22-foot range, but not doing a whole lot. And then some other miscellaneous seas south of there, but again, nothing too ominous, looks obvious. Let's take a quick look at current conditions. We're going to start by looking at buoys up in Northern California off of Point Reyes, buoy number 029. We're looking at all the energy that's hitting that buoy from really long period, 33.3 second period energy. We see a tenth of a foot of energy there, but most of the energy, we see a spike at 15.4 seconds. Another spike here at about 9 seconds. More size, 5.8 feet at somewhere around there, just that one reading at 9.1 seconds, but it's all the energy under the curve that matters for both these two swells. And our graph goes the whole way down to 5 seconds, pure wind chop. Putting this all together, primary swell, 6.3 feet at 14.7 seconds from 270 degrees. That's 10 foot surf. It's big and unruly, and that's probably about right. With secondary swell of 10 feet at 9 seconds from 190 degrees straight out of the south. That too is about 9 foot, so two 9-foot swells do not combine together to make an 18-foot wave, unless you're maybe in a boat, but otherwise from a surfing perspective, it's two 9-foot swells. Then we go down to Southern California, Point Loma South, buoy number 191. We see a more reasonable swell profile with energy anywhere from 20 seconds down to about 13 seconds, all sort of piled together, with wind swell tagging along behind that. Primary swell, 5.7 feet at 16.7 seconds from 268 degrees, and that is inside the Channel Islands. So, theoretically surf 9 foot, something like that, with secondary swell 5.6 feet at 13 seconds from 271. Notice these swell angles here, very westerly. They do a much better job of getting through the Channel Islands, and surf from that secondary swell 7 foot. So there is surf in Southern California. Then we go to Oahu, the Waimea Bay buoy number 106. We see a nice spike of energy at about 14.3 seconds with, again, a good bunch of wind swell down below that. Put it all together, primary swell, 7.8 feet, 14.2 seconds from 338 degrees. That's theoretically 11.1 foot surf Hawaiian. With secondary swell, 7 feet at 10.7 seconds, again from 330 degrees. And that's surf at 7.5 feet. So there is surf in the Hawaiian Islands as well. Everybody getting a piece of the action. So where's all this coming from? Let's go back in time. We're going to Tuesday, the 13th of February. A gale developed on the dateline there with about, well, 32.1 foot seas. These are the highest seas over this entire domain. There's the coordinates at 35.75 north and 174.5 east. You get the idea there. Max winds, theoretically 48.9 feet in that fetch area. We put this into motions. Seas continued building to 35 feet into Tuesday evening. And then on Wednesday, the gale developed more with 54-knot winds, seas building to 38.8 feet to 39 feet. Wednesday afternoon, 38 feet in the evening, and by Thursday morning, the gale was fading with 35.8 foot seas, pushing off east. All that energy hit Hawaii, it looks like on Thursday sometime, and then pushed towards the U.S. West Coast. Swell from that system hit Northern California on Saturday, and then into Southern California on Sunday, with the new gale developing right behind that with, well, there you are, 32 foot seas aimed off to the east. All right, so let's go look to the future. What's to come? We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, just like right there. Why do we look at that? Because that helps create that's known as a trough, that dip in the jet. That creates a counterclockwise circulation up in the jet stream level that also manifests itself down on the ocean surface. And of course, the hallmark of low pressure is a counterclockwise circulation. And if low pressure is deep enough, it generates stronger winds. Winds eventually get traction on the ocean surface, imparting energy to the ocean. That creates a raw sea state. As those seas migrate or radiate away from the fetch area, the shorter period elements get groomed out. You end up with swell, and of course swell, when it hits your beach, turns into surf. So we have one trough here. We have maybe another trough developing here off Kamchatka in the North Dateline region. Let's put this into motion and see what's to happen. The trough off California continues Monday into Tuesday. The trough over the North Dateline region pushes into the northwestern Gulf of Alaska, but notice that the jet is well split right here. Typically, when you get that, that's not a good sign. You get high pressure in between. Does nothing for swell production. Anyway, we're into Tuesday here. The trough continues off California, and look at that, full atmospheric river vent. The jet just screaming onshore over Southern California up to Morro Bay or something like that, maybe even up to Big Sur sort of thing. A wild and windy event. The title of the event is, like, what is it? Is winter over? Let's see, right here we go. Is the end of winter near? Well, this is kind of painting the picture. When you see this split, this at a minimum tells you there's not a lot of energy in the jet to support gale development, to dig out troughs, and that hints that at least for a while things are not looking good. Then beyond that, we look at the MJO to see if something's going to happen to help impart energy to the jet and to consolidate it, but we'll save that discussion for a couple of minutes. Anyway, as we're into Tuesday night, looks like the trough about ready to push on to California, and there goes pushing onshore on Wednesday. The trough, the second trough up here in the Gulf of Alaska, pretty much getting cut off from the jet. Here's your split flow, one here on 45 north latitude, the other down around 25 south, and just a big old pile of nothing in between other than one cutoff low off the coast of California. Thursday into Friday, falling south, and really, there we go, trying to move onshore on a week out, 180 hours out, Sunday night into Monday off of California. But after that, a heavily split jet stream, things not looking particularly optimistic for either precip or for storm production for surf. So let's take a look down at the ocean surface level pressure and surface level winds. Here's our gale off the coast of California, 40-knot winds aimed at the California coast. Another little gale in the North Dateline region with 35 to maybe 40-knot west winds, and then some other bit of disturbed area northwest of Hawaii. Put this into motion. The one well northwest of Hawaii just quickly getting sucked up to the northeast, offering nothing. By Monday, the gale off of California actually looking fairly weak, trying to move onshore, kind of falls apart. Then we have a new trough pushing off Kamchatka as we get into Tuesday night, Wednesday, 50-knot winds, pushing into the the Aleutian Islands, western Aleutians, and then up into the Bering Sea, and of no interest by Thursday. The other little low tries to organize off of California, just can't do it, only has 25 or 30 knot winds. Circulates off the coast. Will it move onshore? Theoretically, maybe. Also a week from now, up in the North Dateline region, a little low with 40 knot to 45 knot west winds. Low off of California fades. High pressure starts building. It kind of smells like the start of spring with high pressure in control everywhere. Let's go look at the effect of these winds on the ocean surface. And here we go. Significant wave heights for the North Pacific Ocean for the next week. Significant wave heights are the highest 1/3 of waves in any fetch area, so 32-foot seas off of California. So we get into Monday, that quickly fades to almost nothing by the evening. Low pressure in the northwestern Gulf of Alaska, not doing a whole lot, but a new gale builds off of Kamchatka. We saw that on the previous charts. As we get into Wednesday, seas to, about 39 feet. But you notice here, the line, if you were to draw a great circle path coming into California, that is, those 39-foot seas are mostly shadowed, so it's really about, it's got to be able to get under this dip here in the Aleutian, so 36 feet, something like that, aimed at California. New little low building off the coast, though, and relative to Hawaii, well, most of this energy is aimed off to the east, so maybe some little sideband energy into Hawaii. And then we go into Thursday, the low off the coast, just looks like a 23-foot seas aimed at California. So some surf there maybe for as we get into Friday or so and into the weekend. After that, things looking pretty quiet. We're out a week. Maybe a little something over the North Dateline region and in the Northern Gulf. But compared to what we've been experiencing the past month, it seems like things are going to get much quieter. Then we go take a look, local wind forecast. Well, here's California here, Southern California, Central, Northern California, Hawaii out here. Low pressure, south winds, 20-25 knots. It's at least that. It's just a blown out mess up here off of San Francisco. Relative to Hawaii, the winds finally starting to get more of a northeasterly tilt to them today. Let's see how we end up on Monday. There's high pressure. Trade winds back in control for the Hawaiian Islands at 15 knots or more. South winds still in control for California on Monday. Tuesday, south winds moderating for California, mainly Northern California, 15 knots. Light trades for the Hawaiian Islands. Wednesday, a lighter wind regime for California, at least for a moment, maybe even northwest at 5 for Central California. Trades for the Hawaiian Islands. Thursday, a little bit of a south wind flow, 10 knots for Northern California, trades for the Hawaiian Islands. And then as we get into Friday, a southeast to almost east wind event for much of north down into Central California. Stronger trade southeast wind thing for Hawaii. Saturday, offshore for California. Trades mostly for the Hawaiian Islands. Sunday, there comes your south winds again. Theoretically, we'll see how this low really evolves. I don't put much stock in this forecast at this early date. And still a trade wind regime for the Hawaiian Islands, and there we are a week out. Potential for rain. Well, here we are, 4 o'clock on Sunday. It looks like rain the whole way down to, at least Point Conception. Just looking out the window, it's raining here, though it was pretty dry all afternoon. This is just the beginning. You see the beginnings of snow in the Sierra. As we get through the evening, by Monday morning, a big snow event theoretically for the Sierra, solid rain for the whole way down to maybe LA County and north of there for Southern California. and then trying to work its way down to San Diego in the evening, but pretty light. And then finally Tuesday night, just barely reaching San Diego as the whole thing falls apart. Tuesday morning for most of California, light rain, slowly fading through the day Tuesday, maybe getting a little enhancement Tuesday afternoon into Wednesday morning. And then it looks like finally clearing out as we get into the day on Wednesday. Next system off the coast on Thursday, Friday, but I don't know that much of any of it's going to work its way into California in the form of precip. And there we are, well, maybe on Sunday night, some little bit of rain for maybe the whole state. Notice massive high pressure building out here. Is this the beginning of the springtime north wind pattern? Sort of seems like it, with the jet splitting and the storm track just sort of falling apart. We'll keep our eyes on it. Next Sunday, we'll have a much better handle on the situation. But it also suggests finally cooler temperatures for the Pacific Northwest and the Whistler area. They've been plagued by a lot of warm temperatures and very, very high snow levels. Maybe a little too late. We'll see. But maybe there's hope still. Snow forecast dashboard for Palisades, Tahoe. Total accumulation, this is over to the 10-day GFS model run. What's that put it about? 54 inches, something like that. Most of it happening right now into like Wednesday sort of thing. But then theoretically another foot or so on the 26th. Looking at Kirkwood, a little bit less, down to about 48 inches or so, but the same snow profile. And Mammoth, even less with 34 inches, and all of it pretty much happening over the next 24 hours. Then we go look at the snow levels. This is the base of Palisades, Tahoe at 6,200 feet, that black line right there. The blue line up here is the summit, top of Granite Peak at about 9,000 feet. We see, the red is liquid precipitation, if there is precipitation. The gray line right here, that's anywhere from 35 degrees down to about 32 degrees. The interface between the gray and the white line is the 32-degree freeze line. And then once you get into the blues, then that's where you're really into solid snow production. So you see this afternoon and evening high snow levels, but as we get into the morning of Monday the 19th, snow level, freeze level, the whole way down to the base, falling down to 5,000 feet on the 21st and even down to 3,500 feet later on the 22nd. But then we have this big warm-up the 22nd, 23rd, 24th with almost above freezing levels the whole way to the summit, only to then fall deep into cold territory for a couple of days and then theoretically warming after that. We'll have to see. But for right now, freeze levels and snow levels decent for Tahoe resorts. Rain percentage of normal. We're just going to go right to percentage of full season normal rainfall to date. We'll start in Northern California, about 65% of normal. Oh my. But then you get down to the San Francisco Bay Area, we're about 70% of normal, something like that, which is about what syncs up with my rain gauge in the backyard and seems about right. Another 5 inches of rain or something. Let's see. Well, actually, here's where are we at right now. These are the amounts, the actual amounts. This is what you need for a full season. Typically about 20 inches is what I shoot for a normal. Looks like, honestly, we're about on track for this time of year. Then we go to Central California. Things are doing much better. Probably, it's kind of all over the place, but probably 85% of normal, maybe even more for the entire season. Southern California, yes, 100% at least of their full normal rainfall for the season. So, California not doing too bad. This El Nino has been kind of a weird one, but as of right now, it looks, if we get 100% of normal precipitation in most areas, that would be a good deal, a blessing as we get into the summer. Surf spot forecast will start in Northern California, Ocean Beach. Another pulse of swell coming as we get into Monday. Large waves, but you also see the wind 27 knots out of the south. That size eventually trickling down as we get into Wednesday, Thursday. Maybe a little bump on Friday from the local gale off the coast. Then after that, things settle down considerably. Pure swell sizes, 16 feet at 15 seconds on Monday, trickling down into the 11-second period range as we get into Tuesday and Wednesday, 5 to 6 feet. Less than that. And then another little pulse, 6.5 feet at 14 seconds on Friday, and then fading from there. Let's go take a look at Southern California. Here we go. Pulse of swell was this 11-foot surf. As we get into Tuesday in Southern California with light south winds, then size slowly trickling down, a little bit of another pulse as we get into Saturday, 3.5 foot range, fading from there, with swell sizes 7.5 feet at 15 to 16 seconds on Tuesday, dropping down, and then that other little pulse at 2.5 feet at 14 seconds on Saturday. Then in Oahu, bigger surf, at least for the moment, but it kind of doing this dropout thing, suggesting a lot of wind swell, 15 feet, falling to 10 feet as we get into Monday, down to 4 feet on Tuesday, then sort of plateauing off in the 5 to 6 foot range for the middle of the work week, and then a little pulse as we get into the weekend on Saturday, 9-foot surf, and with trades, look at this, arrows all out of the east, finally, after it seemed like a week of north winds. Swell sizes, 11 feet at 13 seconds, fading to 8 feet at 11 seconds. Another little pulse in the 4 foot, 4.5 foot range at 13 to 14 seconds for midweek, and then another pulse for the weekend, 5 feet at 17 seconds. And the beat goes on. All right, let's go to look longer term. There's two oscillations we monitor, the MJO, the Madden-Julian Oscillation, and of course the El Nino Southern Oscillation, ENSO. We'll start first by looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. It's this periodic weather oscillation, 2 phases, active and inactive phase. Active phase on one side of the planet, inactive phase on the other. They rotate around the planet, west-east on the equator. The active phase is a low-pressure system. When that active phase moves over the Pacific, it dampens trade winds. That, in turn, takes warm, moist air that's at the ocean surface, lifts it aloft up into the jet stream, feeds the jet stream. A stronger jet stream produces better troughs, which produce storms, which produce surf, and also snow. The inactive phase, a high-pressure system. It effectively steals energy from the jet stream, cutting the jet stream off from the warm, moist flow, and then you end up with high pressure, a very split jet stream like what we have now, and not good support for storm development. That's not to say there can't be storms during the inactive phase, just that probability-wise, the odds are not in their favor. So we're looking at winds on the equator. This is the East Pacific here. This is the West Pacific here. There's the equator right there. The date line's right there. This is data from the TAO buoy array, series of buoys strung across the equator, used for monitoring El Nino. There's wind sensors on those buoys. We can just look at 5-day average winds. We see winds out of the east in the East Pacific, trade winds, not super strong, just kind of moderate. Same deal over the Central Pacific, same deal over the West Pacific. But it's not the actual wind speeds. It is the anomalies, the difference from normal for this time of year. We see trades maybe just a hair bit stronger than normal over the East Equatorial Pacific. But look at this. We have westerly anomalies on the date line, so sort of suggestive of maybe the active phase of the MJO, or at least the last little remnants of it, or even El Nino, because the El Nino basically is like a long-running active phase of the MJO. Okay, we're going to have to pick a little bit deeper to see exactly what's going on. But for right now, for the moment, it still looks like conditions are somewhat favorable to support storm development. Let's go look at the forecast 2 weeks out. Here we are, 850 millibar zonal wind anomalies. This is just the east-west component of the wind. Are the trades blowing stronger than normal or weaker than normal? The blues are stronger than normal trade winds. That would be loosely associated with the inactive phase of the MJO. The reds and oranges, westerly anomalies, associated roughly with the active phase of the MJO. But this is the whole plan on one chart. We need to just look at, really we're interested in what we call the Kelvin wave generation area, or the West Pacific. Dateline's right here. That's a good place to start. Far West Pacific ends at 125 east, so this area right in here. Or you can go the whole way up. You can look at past performance here. And here you see it. Westerly anomalies in January, active phase of the MJO, holding the whole way through to February 18th. The forecast says maybe the 19th. And then after that, easterly anomalies set up. Yes, maybe some westerly anomalies, but for at least the next week to maybe 10 days, looks like easterly anomalies in control. So that might explain the split jet stream that we saw on the charts forecast a week out, and probably the lack of potential storm development and rainfall as we get deeper into the forecast period. All right, let's dig a little deeper. We're looking at outgoing long-wave radiation, OLR, cloud cover, basically. If the active phase of the MJO is a low-pressure systems generate clouds. If the inactive phase is a high-pressure system, high pressure dampens cloud, produce clear air. So, outgoing long-wave radiation is a measure of the amount of sunlight bouncing off the ocean surface. Blue, negative anomalies, means more clouds. Sunlight can't bounce off the ocean surface if there are clouds above it. Okay? So, and the blues roughly would be the active phase of the MJO. The oranges, the inactive phase, clear free skies. Let's get ourselves oriented. South America, Central America, Hawaii, New Guinea there. EQ, the equator right there. Dateline right there, the all-important Kelvin wave generation area right here. This looks like the active, and this is a statistic model, active phase of the MJO moving east out of the Kelvin wave generation area. Inactive phase of the MJO over the maritime continent starting to move towards the Kelvin wave generation area. Same pattern holding as we go 5 days out. 10 days from now, inactive phase in control. And 15 days from now, that would be 2 weeks, inactive phase strongly in control of the Kelvin wave generation area. Per the statistic model. The dynamic model looks like it's starting to come on board with that too, suggesting right now we're probably in the last little bits of our active phase. Weak inactive phase sets up for the next 5 to 10 days to 15 days, while the next active phase builds over the maritime continent. Let's go even deeper. Phase diagrams. We can drill in deep with the statistic model here, the dynamic model here. This shows you exactly where the active phase is and how strong it is. How do you read this chart? Well, the MJO moves from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. So in the far East Pacific, actually maybe even in the Atlantic already, if the dot is close to this circle, the active phase is considered to be extremely weak. So a weak active phase, we'll say over Florida or something like that. And forecast to move to either the central to the East Indian Ocean 2 weeks from now, and ranging from either very weak to moderately strong. The dynamic model, the GEFS model, puts the active phase about in the same place. In the far East Pacific moving into the, in the far East Indian Ocean, moving to the maritime continent, and, moderately weak. Another statistic model here, this is just showing sort of like outgoing long-wave radiation, potential for precipitation. The greens, favorable for precipitation, the oranges and reds, dry air, so active phase of the MJO, inactive phase. South America, Central America, there's your equator right there. Dateline roughly there. There's New Guinea. Looks like the inactive phase of the MJO today moving into the West Pacific, making its transit across the Pacific. You can literally see it just following across here, with the active phase finally starting to show up maybe March 9th. So today is the 18th, so maybe 3 weeks from now, a hint of a weak active phase starting to build in the far West Pacific, and then that continuing on deep into March. So for right now, it kind of looks, at least by these models, that we're in some sort of a break. Let's dig even further and deeper. Back to 850 millibar zonal wind anomalies, this from the CFS model. The date line runs right up the middle of this chart. The oranges and the reds, westerly anomalies, the blues, easterly anomalies. But we see there's a line, MJO, the black contour. Dotted contour, inactive phase. So here we are back in November, inactive phase of the MJO. So we get into December. Here was your active phase with westerly anomalies, supportive of storm development. And we had those our first bout of major atmospheric river events in California. Then late December, January, inactive phase. Things settled down. Here we are now, our current active phase, or what's left of it, look like it's all but fading out. Maybe a day or two of westerly anomalies left in the Kelvin wave generation area. Then we kind of fall into this funk with weak easterly anomalies, pockets of westerly anomalies, no MJO signal at all, just kind of a neutral pattern. That's not too bad, but it's not actively imparting energy to the jet stream either, and that's why the GFS model is showing that split jet stream, and that looks like that's probably what we're going to see a fair bit of here for quite a while. Let's go look out even further. Here's the CFS model going out 3 months. Past performance in the bottom here. The forecast up here, it actually looks pretty good, but let's go back. So the date line runs right up the middle, the oranges and reds, westerly anomalies, the active phase of the MJO. So you see some sort of an active phase in October, another in November, another in December. We had an inactive phase in January with easterly anomalies kind of shut things down. Here is our current pretty big active phase starting to wrap up now. And you look at the model and you see westerly anomalies forecast actually for the next 3 months. They're just light. They're not strong. We can overlay the MJO here. So active phase, active phase, active phase, active phase. But here we have westerly anomalies, probably from the El Nino base state, with this dotted contour, inactive phase of the MJO in control. They sort of negate each other. The inactive phase trying to steal energy from the jet. There's still the westerly anomalies from the remains of El Nino. They just sort of end up with a neutral pattern. We don't really get a true active phase of the MJO until somewhere around late March into the whole way into the end of April. So this would be our next potential target, but by then we're in springtime. That's not to say you cannot have decent storms as we get into April, but they're certainly not as strong as they would be as if you were in December, January, February sort of time frame. Let's overlay the low pass filter here. This is the solid contour, low pressure bias, the El Nino base state. 1, 2, 3, 4 contours back in November, December into January. We still have 3 contours even now holding till the end of March, so there is still plenty of opportunity right in here. And then El Nino finally starts fading in the Pacific. 2 contours as we get into May and 1 contour after that. So you see we're on the downward swing of things, but still there is hope. So now we go into the El Nino or the ENSO portion of the discussion. What is the state of El Nino? We're starting by looking at data down in the ocean. East Pacific here, West Pacific here. These are down 100 meters, 200 meters, 300 meters. We're not looking for signs of Kelvin waves. We're just looking to see the balance of warm water. Is there more warm water in the east than in the west. You can kind of look at the graph right off the get-go and see what's going on. These little X's here are anchor lines on the TAO buoys. The X's are sensors on those anchor lines. The sensors collect temperature data and then use a model to fill in the copious gaps in between. And we see the 30-degree isotherm, which was over at 180 a week or two ago, and even further, quickly receding off to the east. It's at 166 or 167 east today. The 29-degree isotherm, which was over somewhere in the 160s, backtracking to 177 today. The 28-degree isotherm, which was at a minimum at 140 and at times over to 120, it is backtracking to at 154 west today. And the 24-degree isotherm trying to hang on. Oh, look at the 28-degree isotherm. Still one last little pool of warm water right on the surface here. But you also get the sense there's much cooler water lurking underneath. But we don't need to look at the means. We can look at the actual anomalies. Difference from normal for this time of year. This really paints the picture. The last of the... Yes, it was 9 Kelvin waves. We'll get into that in a second. Not 8, but actually 9 Kelvin waves. The last of the warm water from the 9th Kelvin wave, this last little pocket right here, in fact. You can see it right there, right here. 3-degree anomalies lingering at, what is that, about 25 meters down from the surface, slowly getting squeezed to the surface. 2-degree anomalies over a little bit bigger area. There's the 0 line with cold water pretty much encroaching the whole way under the Pacific, the whole way to Ecuador, squeezing, trying to get to the surface, and what it's doing is pushing that warm water up to the surface right here. So you'll see it on some of these surface anomaly charts. Warm water, you go, oh, it's a Kelvin wave. No, it's just the last of the El Nino warm pool getting squeezed to the surface. And then the trades take all that warm water, and you can see it here sort of building it up this way. And you go, oh, maybe that's a Kelvin wave. No, trade's stronger than normal. All this moving, and you can see it actually in these charts here, building up in the West Pacific. The end of El Nino. This is pretty typical. The trades have, are building back. The westerly anomalies from 8 or 9 active phases of the MJO from starting a year ago have just given up the ghost. The cycle is changing. Here is a different version of that image. It's not only using the sensors from the TAO array, but it's also using satellite data to enhance it and clean it up a little bit more. You still see a good pocket. Now this says 4 to 5 degree anomalies right here, but this is Ecuador is literally right there. You see this very thin pool, this cold water here trying desperately to squeeze to the surface. It will probably poke through in the next 2 weeks, isolate all this warm water here, and it'll just disperse. And then you see the lingering warm pool from all the previous Kelvin waves moving off to the east. Actually, I meant moving off to the west. All right, here's your satellite data. Pentad sea level anomalies. This is your satellite data. It's just the satellites rotate around the planet. They tell you the height of the sphere of the ocean. Why does that matter? Well, if you have warm water at depth, it will expand. When it expands, it displaces the water above it and creates a bump on the ocean surface. If you have cold water at depth, it contracts, you'll get a little divot on the ocean surface. And this data, strip out the waves, the wind waves, the tides, and that's how you get the sphere. All right, so the equator right here, dateline right there, there's New Guinea there, the Galapagos, that little squiggly line there, and there is Ecuador. You see warm water all along the coast of Ecuador down into Peru, but from the Galapagos out to 130 west, you see negative anomalies here. Here's your last little bit of your warm pool sort of here on the equator. And it's only 5 degrees north and south of the equator that matters. So last of your El Nino warm pool there and there with nothing in flight to suggest that any more Kelvin waves are coming. And atmospherically, there's just nothing there to support it. So we're hanging on, waiting for the, this is subsurface temperatures now, down deep in the ocean. We'll go look at the surface temperatures and see what that tells us. Sea surface temperature anomalies. Surface, not subsurface. There's Ecuador, there's the Galapagos, the equator's right there, Hawaii out here. You can see above normal temperatures for all of Ecuador down into Peru, continuing out to almost the date line, right? But you see this little areas of cooler temperatures embedded in, not cold, just cooler, the slowly fading remnants of El Nino. But still, clearly, an El Nino-like signal. But we know at some point cold water is going to start poking out here at some point. Sea surface temperature trend for the past 7 days, and all we're looking at 5 degrees north and south in the equator. Yeah, we see generally warming temperatures off of Peru and Chile. I think that's more of a seasonal sort of thing. But right in here, a little pocket of cooling right by the Galapagos. But otherwise, here's your 1, 2, 3 pockets of the last of the warming getting squeezed to the surface. In fact, this area was really showing bright, almost bright red a couple of days ago. We suspect as the last of the warm water gets squeezed to the surface, this will slowly get cooler and cooler, and then all of a sudden, maybe as early as even next week, we'll look here and you'll start seeing dark blue, cooler anomalies showing up. The beginning, potentially, of La Nina, or at a minimum, certainly the end of El Nino. But for right now, everything looks very much El Nino-ish like. And even if these temperatures were to get cool all of a sudden, there's way too much momentum in the atmosphere. It's not like all of a sudden we're going to just switch to La Nina and that's the end of it. No, there's enough momentum. It took us a year to go from La Nina to El Nino. It will take us a year to flip back the other way, to go from a El Nino pattern to a La Nina pattern. So even as we're into November and December of this coming year, there will still be vestiges of El Nino in the atmosphere. And that's good, I think, for our snow forecast for next winter, not even this winter, next winter. Maybe not so good for surf forecast. Maybe early part of the fall will look good. But as we get deeper into January, a year from now, the storm machine will take on a decidedly more La Nina-like template or pattern. I forgot to show this earlier when we were looking at the subsurface temperature. So here is the data from altimetry showing, you can literally see this is the West Pacific here, this is the East Pacific here going back in time, and you can see your Kelvin wave count. I think I missed this on another chart as well. But anyway, so there was one Kelvin wave back in December. You can't see it. It's right there. That was number 1. Number 2 in January. Number 3 in March. Number 4 in April. Number 5 in June. Number 6 in August. Number 7 in October. Number 8 in November. And look at this right here. This is number 9. In January, we were like, are we going to get another Kelvin wave? Are we going to get another Kelvin wave? And I think the answer is yes, technically we got one. You can see its signature here, but from an atmospheric perspective, does it make any difference? And the answer is clearly no. And then here's the subsurface normal chart we look at. It doesn't show that Kelvin wave number 9. I mean, it would be like right in here, but you don't see it. But the current state is, you can see here, here's your colder than normal water making its way the whole way across the Pacific. The interesting part here is there is a little bit of warming showing up. I think this is more surface level warming that's just kind of digging its way down into the ocean a little bit and sort of skewing the image. But I think, honestly, everything here, for the most part, is colder than normal temperatures. But as you can see at the surface, everything looks normal, but we know danger is lurking only literally 25 meters away, down 25 meters. But purely on the surface, if you're in the Nino 1.2 region, this is the area right there by the Galapagos in Ecuador, temperature's actually looking pretty good. 859 thousandths of a degree above normal. We're actually higher now than we've been for the whole month before. But again, It's kind of a fake out. That is the last of the warm water getting squeezed to the surface, knocking the index up temporarily, but I think that will be short-lived. Then we go to Nino 3.4, the official area. This is starting at 120 west, so on the equator south of California, the whole way out to the date line. This is not the official numbers, but it gives you the trend. Today's value, 1.184 degrees above normal, so still in... Well, weak El Nino is 0.5 to 1 degree, moderate is 1 to 1.5 degrees, and strong is 1.5 to 2 degrees. So, yeah, theoretically bordering on strong El Nino. Let's go look at the weekly data. Here's Nino 1.2, here's Nino 3, here's Nino 3.4. Right here, that's the magic number for the past week, 1.7 degrees. That's the official value. So that would still put us in strong El Nino territory, and we have been pretty much the entire month of January. Last week, we looked at the actual numbers. We'll do that real quick. And for January right here, we came at 1.87 degrees. For November, it was 202. For December, 202. You put them all together, the number, at least the tentative number right now, is 2.0, which is exactly gets us bare minimum super El Nino status. But compared to any of the other super El Ninos, they were all up in the 2.2, 2.4, 2.5 range, and not just for 1 month, but for multiple months. So we're officially a strong El Nino. Sea surface temperature trend spatially, you can see it, East Pacific here, West Pacific here. You can see there was your peak of El Nino, your hottest temperatures right here in the December, we'll say November, December, January. Official El Nino region, 120 west to 170 west. So right here to here, and you can see all the temperatures now moderating. It's still pretty warm, not doing too bad. In fact, 1, 2, 3, 4, 5 grades. 1, 2, 3, 4, 5. Did I get that right? In fact, let's map this out. Let's see. 1, 2, 3, 4 shades. Where we are, 1, 2, 3, 4. So 1.5 to 2 degrees. So strong El Nino category still, but you already see the beginnings of the demise here. You can see temperatures fading here. So, and there's a little bit of a lag on reporting on this chart as well. And what does the atmosphere think is going on? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin roughly in the Indian Ocean. When pressure is lower in Tahiti, the index goes negative. Today's value minus 3.99. Okay, and that is what one would expect during El Nino. In fact, you go back here and look, and we have been strongly negative for, I think it's like 27 or 29 days now. And our peak was minus 46.54. Now that's just 1 day. And then we go look at the 30-day average. Well, we're getting respectably down there now, minus 18.42. Day late and $1 short. This guy should have been down probably minus 20 or 22. And that should have happened back in December, but no, we were like near neutral then. So we're moving in the right direction, but for whatever reason, this El Nino wasn't fully coupled with the atmosphere, or the atmosphere didn't completely get the message. The 90-day average, minus 5.75. We should have been down at minus 15, or at 12 at least. We never even came close. Let's look at this data on a graph. Here we go, 30-day moving SOI all graphed out. Here is our La Nina trend. There's 0 right there. If you're positive, well, that's your La Nina. We were back in 2022. January 2023, steadily falling downward into June, and then this El Nino just lost its mojo in June and July, you see. And this might have been some effect of the PDO, might have been other things. Then as we finally got into the fall, yeah, we were down at minus 12 or so. And then even as we got into January, up at plus 7 or 8, and now finally falling again. I mean, this El Nino just did not do exactly what we were expecting it would do. I mean, we've done okay, but not as kind of a barnstormer as we were hoping for. And then the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. All right, you can see our peaks right at 2 back in December and January, falling steadily from there. Here's February. We're at 1.65 or something, this suggests. And the trend falling off a cliff from here deep into La Nina at -2 degrees as we get into October. Don't believe this at all. It's way too early. We're not even to the beginning of the spring unpredictability barrier, much less coming out of it. That won't happen until June. So in June sometime, we'll have a much better feel for where we're at. And then we'll also be in a position where we can get some data from all the other models, probably by next week. And then we'll, at least we can begin to kind of divine where we're heading towards. But for right now, a stormy pattern continues in the Pacific. Rain for California for a couple of days, snow for the mountains, swell, be it a little bit raw and unrefined. Trades finally setting up for the Hawaiian Islands, though, over the coming week. Much cleaner pattern, but then quickly the storm pattern starts falling apart. The jet unravels. We move into the inactive phase of the MJO. We're probably already there based on this Jetstream charts, and we're just waiting for that to build across the Pacific. The hope is that there is a new coming active phase of the MJO as we get into mid-March, something like that. Maybe that'll give us a nice little nudge in the right direction. We'll get some surf then. At this point now, I'd say if there's surf, you better go get it. If there's snow, you better go get it. The good news is from a snow and rainfall perspective, we're on track for 100% of normal rainfall. Southern California already there. Central California probably 85% of normal. Somewhere in the Bay Area, not quite as much. In Northern California, not as much. But that's not unusual. The focus during El Nino of most precip is somewhere in between Central and Southern California. We're right on line with that sort of a pattern. So take what you can get, make the most of it. Other than that, if you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. That'll get you all set up. If you'd like to make a contribution or a donation, you can use a special thanks button down below the heart with the $sign in it. And other than that, we will see you next week, same time, same channel. Thanks for watching. We'll see you soon.